Alright, 2-1, welcome to Chapter 2, new section, and we are going to jump right in talking about quadratic functions and models. So we're graphing some quadratics here, which is x squared, right? So once again, x squared is squaring. We've been dealing a lot with linear so far. Alright, so definition of a polynomial is coefficients and x to some degree, right? Polynomial of x with degree n. If this was a 5, it'd be fifth degree, things like that. In this section, we're going to be dealing with quadratics. So the largest exponent you can find, the degree, is going to be 2. All right? And so this is our standard form, right? General form, I should say. Standard form we'll have in a couple slides down here. But the general form looks like this, but it could be written in a bunch of different ways as long as our degree gets us to 2, which in this case, even though we don't see a 2, x times x, when we FOIL it, we will get x squared. And just a reminder, if our leading coefficient a is positive, we're going to open up. And if our leading coefficient here, a, is negative, we're going to open down. All right? So let's just revisit example 1 we already know how to do here. Compare the graphs of x squared and 1/3 x squared. 1/3 x squared is going to be 3 times as wide as this because fractions are fatter. On B, 2 is taller than 1, so this is going to be stretched by 2. All right? So 1 comma 1 gets stretched up here to 1 comma 2, twice as tall. Right? 1 comma 1, and this isn't really drawn perfectly because this should be out at 3. It's 3 times as wide. Okay? All right, so let's take a look at this. Actually, sorry, this is your checkpoint. I put them up for you. So go ahead and pause the video. Try this one. Just give me a quick in-word statement of how these relate to y equals x squared. All right, so a standard form of a quadratic function. The quadratic function is given by this. If we can have our quadratic look like this, a, parentheses, x minus h squared plus k, we're in standard form. And it's nice to do this because a couple of nice things happen. All right, if we can get it in this form, the axis, the line that in the graph here that runs down the middle, right, kind of creates our line of symmetry. Then our axis is the vertical line x equals h, so this line here, whatever's in with the x. The vertex is at h comma k. That should sound familiar from our circle formula, right, h and k. And then again, if a opens upward, a is positive. A is less than 0, negative, the parabola is going to go downwards. All right, so let's take this first equation and see if we can move stuff around and identify the vertex and the axis of symmetry on this one. So the key on this, we're going to say 2x squared plus 8x plus 7. First thing, I'm just going to separate these two right here. Just look at those. And what we can do is we can pull a 2 out in front. So now we have x squared plus 4. And I'm going to leave some space over here because guess what we get to do? We're going to complete the square. So if we remember, we cut the 4 in half, we get 2, and then we square it. So we get 4, and I forgot my x on here. So add 4 on here. Okay? Because this 2 is distributing in, we're really adding 8. 2 times 4 is 8. We can't just magically add 8. So we also need to minus 8 on there. All right? So FOIL this, or I'm sorry, factor this. This is a perfect square now. So x plus 2. And again, that's this number. That's the reason we're looking for that number. Squared minus 1. 7 minus 8 is minus 1. And look at that. Now we have it in our nice a x minus h squared plus k form. We want to find the vertex, so the vertex is h comma k. The vertex is going to be negative 2, right, because the minus is already in the formula, and then minus 1. K is negative 1. The axis of symmetry, x equals negative 2, just whatever h is on there, and that would be our answer. And you can verify that by graphing it on your graphing calculator, but you are going to need to have to learn how to complete the square here and make it look pretty like this. All right, so take a look at that, get it down in your notes, then when you're ready, pause the video on this slide right here. This is your example to try. Try 19. All right, so example 3, let's just do one more as an example. So we're going to sketch this and identify the vertex and the x-intercepts. All right, I'm going to just go ahead and try to solve it first. So I'm going to pull out the negative in front. And so now we've got x squared minus 3x. Leave a little space here, minus 8 on the end. Half of 3 is 1.5, or 3 halves, right? 3 over 2. If we square that, we get 9/4. So we're going to say plus 9 over 4. Oh, hold on one second. Let me pause this video. All right, sorry about that. We're back in here. And so we are going to have to cancel that out. Remember, we're really minusing 9/4, so we're going to have to add 9/4 on here, which is 2.25, right? Because you can't just magically change an equation. This is still y equals, still balanced. If we're subtracting, we need to cancel it out by putting something back in that will balance it out. Add the 9/4. Just so we're clear, 9/4 is 2.25. Okay? So now we can clean this up. This is negative x minus 3 halves squared minus, let's see what we got there, 6. And so 5.75 is our equation. And so let's see, the vertex here is going to be at 1.5, 3 halves, comma, negative 5.75. And our x-intercepts, okay, we haven't solved for x-intercepts yet, but we could by making y 0. And so let's solve this. Okay, so first things first, we'll move the 5.75 to the other side, and we're going to get 5.75 equals negative x minus 1.5 squared, and so then we'll divide by the negative 1 and get negative 5.75 equals x minus 1.5 squared. And then how do we get rid of the squared? We're going to take the square root. And can we do the square root of a negative? No, we cannot. We are not going to have any x-intercepts. No x-intercepts. If we were to sketch this graph, okay, we are starting at 1.5 and 1, 2, 3, 4, 5, 6, negative 5.75 here. That's our vertex, and we're opening down. Okay, so if we look at the sketch, we are definitely not going to have any x-intercepts. See if you can figure out all the same things for problem 25. Try that problem. All right, so now we're going the opposite direction. We're going to be given the vertex and another point on the graph, on the parabola, and see if we can write the standard form. All right, so let me write the standard form back up again. So y equals a x minus h squared plus k. We know h and k. Here's our h, here's our k. So let's plug that in first. Y equals a x minus 1 squared plus 2. And now at this point, we don't know the a, but we can figure it out by plugging in the x and the y numbers that we've been given. So negative 6. We don't know a yet, but we do know that x is 3. And so let's go solve this thing. A, 3 minus 1 is 2. 2 squared is 4 plus 2. Let's subtract. We're going to get negative 8 equals 4a. So look at that. Negative 2 equals a. And so we can write our final equation. Y equals negative 2 x minus 1 squared plus 2. All right? Plug in everything that's given and solve for a. Your turn. Problem 47. All right, so now that we know about the standard form, we can move this around and kind of rewrite it here. And I'm not going to go through the long explanation of where these all come from. Right? If you think you can figure out where these do come from, that is definitely worth some extra credit. So if you can explain to me where b over 2a comes from to find the minimum, then knock yourself out, give that a shot. Same thing with b squared over 4a. Okay, suffice that to say, b over 2a, if we use that, negative b over 2a is the coordinate of the x in our vertex. Okay? Once we have that x, if we plug it back in, which is what this is saying, f of the negative b over 2a, that's going to give us our y. Alright, so we can find our minimum or maximum values. Once again, just a reminder, if a is greater than 0, we're going to open up. So we would have a minimum. If a is less than 0, we're going to open down, so we're going to have a maximum. Alright, so let's go ahead and see if we can find them. So here's an equation, and it's given in here, the flight of this baseball. So this baseball starts 3 feet off the ground, takes off at a 45-degree angle, but quickly falls because of gravity. And our job is to find the height of the baseball in feet and the horizontal distance from home plate, and we want to find the maximum height at this point, right? Find the maximum height. All right, so let's go ahead and figure out what to do here. We can't figure out this because this is the vertex. So remember, negative b over 2a for our x. So let's plug it in. X equals negative, our b is 1 over 2, and our a is negative 0.0032. And so let's go to the calculator to figure that out. One divided by 2 times 0.0032, 0.00116, and it's a negative divided by a negative, so that answer is going to be positive. So 0.0016. Doesn't seem right. Hold on. 1 divided by, oh, parentheses problem. The calculator did 1 divided by 2 and then times it by this, which can't do. We want to do 2 times the 0.0032 and divide 1 by that. So that makes more sense. 156.25 feet. So that is our x, 156.25. All right. But we want to know the y value. So we're going to go ahead and plug that back in for our x. So it's going to be negative 0.0032 times 156.25 squared plus x, which is 156.25 plus 3, and hit enter. 81 feet. That's how high this ball is going to end up. All right, so use this formula to find x, and then plug x back in to get our y. See if you can come up with the same sort of thinking and get a good answer on 75. All right, and that will do it for this section 2-1. All right, any questions? Make sure we go over them in class.